What's the derivative of arcsine? Well, I can't really compute this directly. I don't know how to differentiate arcsine right off the bat. So I'm going to try to sneak up on the derivative of arcsine. Now, instead of writing down arcsine all the time, I'm going to give it a different name. I'll write f of x for arcsine x. Just as a bit shorter. Now, what do I know about arcsine? Arcsine is the inverse function for sine. So at least for a range of values of x, f of sine x is x. Right? Arcsine tells me a value that I can take the sine of to get the input to arcsine. So if I evaluate arcsine at sine x, I get x, at least over a particular range of values of x. So if this is true, and if f were differentiable, I could apply the chain rule and differentiate both sides. So let's just do that. I'm just plowing ahead, assuming that f is differentiable. So if I assume that f is differentiable, I differentiate f, I get some mystery derivative. I don't know what it is yet. I'm calling it f prime. At the inside, which is sine x, times the derivative of the inside, which is cosine x. And this is equal to the derivative of the other side, which is 1. So what I know now is that the derivative of arcsine at sine x is 1 over cosine x. So I divide both sides by cosine. But what I really want is a formula that tells me the derivative of arcsine at some point is some other point. Right? I don't want to know the derivative at sine of x in terms of cosine. But I can use a trick. Right? Sine squared plus cosine squared is 1. So if I knew that cosine were positive, I could rewrite this. You should be a little skeptical of this equality. It's 1 over the square root of 1 minus sine squared x. You have to be a little bit worried here because you got to know that cosine's positive. Okay, but let's suppose it is. So if cosine's positive, then I can write cosine x as the square root of 1 minus sine squared x. And now I've got a formula for the derivative of arctan, derivative of f, at sine x is something involving sine x. So I could rewrite this formula as just the derivative of arcsine at x is 1 over the square root of 1 minus x squared. So there we go. There is a formula for arcsine, assuming that arcsine is differentiable. Right? Because what I did is I just wrote down a function that I knew to be true. I mean, I know that f sine x is x for certain values of x. And I just plowed through differentiating it, assuming it was differentiable, and then I figured out what its derivative would have to be if it were differentiable. But note that I never actually verified that arcsine is differentiable. I'm just telling you what the derivative is if it were differentiable. So that's perhaps a little unfortunate. All right, but nevertheless, we're going to use this, and this is, in fact, the derivative of arcsine. Now, we know how to differentiate arcsine. Let's try to differentiate arc cosine. We could do that in the same way. Right? F equals arc cosine, do the chain rule trick. We get a formula for the derivative of arc cosine, assuming it's differentiable, and it is. But I want to do it a different way. I'm going to try to do it a different attack, a different approach on the problem of calculating the derivative of arc cosine. So here's how we're going to start. Take a look at this triangle here. This angle's alpha, and I'm labeling this side to have length y, and the hypotenuse of this right triangle has length 1. Now what this triangle is telling me is that the sine of alpha, which is this side divided by the hypotenuse, is y. And consequently, the arc sine of y is alpha. Now what's arc cosine of y? I'll figure that out. Let's draw another one of these triangles. I'm going to label this side beta, and I'm going to imagine picking up this right triangle and flipping it over. So that then this angle's beta, this angle's alpha, hypotenuse is still length 1, but the side that I labeled y is now down here. And what this triangle is telling me is that the cosine of beta, right, which is this width divided by the length of the hypotenuse, is y. And consequently, the arc cosine of y is beta. Now, why is that significant? Well, this is a right triangle, and the angles add up to 180 degrees, so alpha plus beta add up to 90 degrees, or pi over 2 radians. So that means what? I know that alpha plus beta is equal to pi over 2. Consequently, arc sine y plus arc cosine y, which is alpha plus beta, add up to pi over 2. Now, this formula is interesting in its own right, but think about what it means differentiably. I just calculated the derivative of arc sine, and I'm wondering, what's the derivative of arc cosine? Well, whatever it is, right, these two functions add up to a constant. They're pi over 2. So however wiggling y must affect arc sine, wiggling y must affect arc cosine in precisely the opposite way so as to make this sum a constant. Said differently, right, the derivative of this side has to be the derivative of this side, but the derivative of this side is 0. That means the derivative of arc sine plus the derivative of arc cosine must be 0. That means that the derivative of arc sine has to be exactly the negative of the derivative of arc cosine. And since we know the derivative of arc sine is 1 over the square root of 1 minus x squared, that means the derivative of arc cosine is negative 1 over the square root of 1 minus x squared. My goal right now is to differentiate arc tan x, but that's too hard. So instead, we're going to sort of sneak up on the derivative of arc tan x and figure out the derivative without explicitly knowing it to begin with. So here we go. To make this a little bit easier, I don't want to keep writing arc tan x all the time, so let's give it a different name. Let's just call it f. So f of x will be arc tan x for the time being. Now, what do I know about arctan? Arctan is one of these inverse trigonometric functions. It's the inverse to tan. So I know what f of tangent x is. Well, as long as x is between minus pi over 2 and pi over 2, the arctangent of tangent is just x. So this is a really great thing, right? Now, if f were differentiable, I could use the chain rule on this. So let's just pretend that arctan is differentiable and see what happens. So in that case, I differentiate this using the chain rule. I get the derivative of f at the inside times the derivative of the inside. The derivative of tangent is secant squared. The derivative of x is 1. Right, so I differentiated both sides of this equation. F tangent x equals x. The derivative of f tangent x is f prime tangent x times the derivative of tangent, which is secant squared. And the derivative of x with respect to x is just 1. Now I'll divide both sides by secant squared x. And I find out that f prime of tangent x is 1 over secant squared x. Now what do? I'm trying to write down the derivative of f. F is arctan, and I want to know how to differentiate arctan. And what I've learned is that if f were differentiable, its derivative at tangent x would be 1 over secant squared x. Well, here's a trick. I know the Pythagorean identity. I know that sine squared plus cosine squared is 1. So if I take this identity and divide both sides by cosine squared, I get that tangent squared, right, that's sine squared over cosine squared, plus cosine squared over cosine squared, 1, is 1 over cosine squared, that's secant squared. So here's another trig identity. Tangent squared x plus 1 is secant squared x. So up here, where I've got 1 over secant squared x, I could have written this as 1 over, instead of secant squared x, I'll use the fact that secant squared x is tangent squared x plus 1. I'll put that in here, and I get that the derivative of f, the derivative of arctan, at tangent x is 1 over tangent squared x plus 1. So this is a pretty great formula, right? This is saying that the derivative at something is 1 over that same thing squared plus 1. So a more normal, a more common way of seeing this written is that the derivative of arctan x is 1 over x squared plus 1. So here's what we've done. We've got the derivative of arc sine is 1 over the square root of 1 minus x squared. The derivative of arc cosine is exactly negative that, because the sum of arc sine and arc cosine is a constant. So it's negative 1 over the square root of 1 minus x squared. And we calculated the derivative of arc tangent just now to be 1 over 1 plus x squared. Excellent. At this point, we've calculated the derivatives of arc sine, arc cosine, and arc tangent. And now I challenge you to go and calculate the derivatives of arc secant, arc cosecant, and arc cotangent. Have fun.